Okay, in this tutorial we're going to talk about Newton's first and second law of motion. Newton's first law of motion states that an object at rest will remain at rest unless acted upon by an unbalanced force. So let's say this box is sitting here on the floor. What we're saying is that it must take some kind of force exerted on this box to get the box in motion. So if I were to exert a force in this direction on the box, then the box would begin a motion in this direction. Okay, and it would take some other, and it would remain in that motion until some other force acts upon it, say a wall or even friction, right, on the ground. If I push the box on the ground, friction is going to cause that box to stop eventually. But an object will remain at rest unless acted upon by an unbalanced force. Inertia is a tendency of an object to resist a change in motion. Whether that object is moving or not, it resists a change in motion. Let's take a look at this diagram down here with the purple box and the yellow circle. If a force were to be exerted onto this object, or like let's say a car, for example, if a car was to come to a stop, let's say you're riding in a car and the car all of a sudden comes to a fast stop, right? The brakes get slammed on. Your body would keep moving forward. That's inertia. Okay, it takes a force such as your seatbelt to stop that change in your motion, because the object that hits that the brakes are slowing the car down, but they're not slowing you down. So if in this scenario again, that's like saying that both of these objects are moving forward, right? We'll say the purple box is a car, the yellow circle is somebody in the car, and the car slams on their brakes. So in that situation, you would notice the box would come to a stop and the circle would keep going. Okay, if that was a car and the circle was you in the car and you're driving again, you get close to a stoplight, your mom or dad hits the brakes to kind of stop the stoplight, you move forward at least a little bit until your seatbelt acts upon you and pulls you back into your seat. That is inertia. Take a look at Newton's second law of motion. Newton's second law of motion basically tells that the force is equal to the mass times the acceleration. So an example of this would be if, let's say, a baby's sitting, or let's say somebody's baby. Let's say you're babysitting and two children are in a wagon, and they like when you take off quickly. You're pulling a wagon, you take off running, and the kids, wee, right? So when that happens, you have the force, that you're exerting on the wagon, and it's proportional to your mass and an acceleration. How fast you accelerate, how quick your remember, it's a change in acceleration, a change in speed over time. So when you go from walking slowly or you're stopped and you take off real fast, that's your acceleration. Because you're bigger and heavier, you're able to move that wagon quickly, and like I said, that's when the kids have fun. But then let's say they flip that and now you get in the wagon and the kids want to pull you. Well, because they're lighter, they're not going to be able to exert as much force because they don't have as much mass. And in that situation, there's more mass, right, you in the wagon, than the individual pulling it, the little child. And so you're not going to have a lot of force, and it's not going to accelerate very fast. And so another example with that would be, if you've ever walked a dog, and the dog's taking off and they're pulling and everything else. Well, in this scenario here, this first picture, the dog is much lighter than the individual walking the dog. And that's why, the dog's not going to really be able to, it's not going to be able to exert enough force. Okay, this dog's not going to be able to exert enough force on the person to really cause the person to move forward. But, in fact, the person is exerting more force on the dog in this direction to keep the dog from taking off. But let's look at like a person with an empty shopping cart. if you've ever pushed a shopping cart before, you know that because your mass is so much more than the mass of the shopping cart, then you can take off real fast and start running it. You're able to exert a large amount of force. So again, when you're talking about force, you're talking about the your force is going to be equal to the mass of the object times its acceleration. So again, the heavier something is, the more mass an object has, and the faster and the more it's accelerating. Okay, the quicker that speed changes over time, and the more force it's going to exert. We can also say that acceleration is the net force divided by the mass. So, in other words, you're in a car and you take off. The amount of how much force is exerted on that car by the engine divided by the mass of that vehicle is going to tell you what the acceleration is. That's why if you have a light car like a Corvette, it's going to have a lot more acceleration than, say, a big semi, because a semi has so much mass. Let's take a semi for a minute. If you have a semi that has nothing on it, an empty road, obviously it's going to be able to accelerate faster than if it has a full load on the trail. Now let's look at one last concept, and before we wrap this up, and that is a newton. Okay, so then what is a newton? A newton is going to be an object's mass times the object's acceleration. Okay? That is what a newton is. An object's mass times its acceleration. So, in writing this, I can say that force N is equal to the mass, again, represented with the lowercase m, times the acceleration of that object. And formula-wise, I would say F equals ma. Okay, that's how I'd write that. Force equals mass times acceleration. And that discusses Newton's first and second law.